Hello, Math 112 students. Today we're looking at section 5.3, which is focused on the graphs of the sine and cosine functions. So we talked about, hopefully you were there in class when we talked about how if we did like I talked to you about a noodle lab that I used to do, where you make a circle with a radius of one noodle all the way around. So this would be one unit, where the unit is a noodle. Then you take the rigid noodle and you have these angles, like let's say this is 35, this is 45, and this is 60. Sorry, this is 30, 45, and 60. And the sine of this angle is the vertical part, right? It's this vertical part, which because that's the sine is opposite over hypotenuse. It's this, the opposite side is the vertical, the hypotenuse is that. So it's the ratio of this length over this length. But since this length we know is one unit, which in this case is one noodle, then this divided by that is just that length divided by 1. So it just boils down to that length. So we take the rigid noodle and we lay it down right here and we break it off right there, so that now we have a piece of a noodle that's that long. And so we make the sine wave, like if we're here, if we're at 0, we have the vertical, there's no vertical at all, so there's no noodle at all, so it's 0, 0. And then 30 would be this length, and if we did 45 it'd be taller, and 60 would be taller, and 90 would be all the way to 1. So 45 would be this tall, and 60 would be this tall, and 90 would be this tall. And then we got to 120, it would shrink back down again, and we'd have these values. And when we got to 180, it would just be a flat thing, so there would be no vertical length at all. So we then have this sine wave. And when we get to past 180, we have these negatives. And so then it goes kind of like that. Where you're at 270, you're at a whole -1 length, -1 noodle, +1 unit. So you go all the way down there and come back up. So that's how, that's what produces the sine wave. And as you keep going around the circle, this thing would just repeat itself in a cycle. When a graph repeats that, it's called a periodic function. And when you go through a full cycle, we've gone all the way up here, all the way down here, and all the way back where we started, and we're going to repeat the cycle. That's called the fundamental cycle. And so when you know something about this curve, it really, you can get the curve by boiling it down to 5 points. The point at the beginning of the cycle, the point where the cycle hits its maximum, then the point where it comes back to the center line again, like it was at the beginning, then the point where it goes all the way down to its minimum, then the point where it comes to that center line one more time. And that means it's gone through its full cycle. And it's going to just repeat that cycle again over and over. So you can define the sine function by 5 points, those 5 points. And so for all these, we're going to try to focus on getting those 5 points. If we were doing cosine would be the adjacent side. It would be, in other words, for this angle here, it would be this part, the horizontal, the ratio of the horizontal, which is the adjacent side, to the hypotenuse, which is that. And again, if the hypotenuse is 1, then it just boils down to the horizontal piece there. So I've got this. So it's just this then. And so we take those lengths for cosine, and when we're at 0 degrees, we have one full noodle in the horizontal direction. So cosine, when you're at 0 degrees, starts at 1. And then for 30 degrees, it would be this length. Then for 45 degrees, it would be this length. And for 60 degrees, it would be this length. And so it's getting shorter until you get to 90, and it wouldn't have any horizontal length at all. It would be no noodle. So 30, 45, 60, 30, 45, 60, 90. So then this thing would start at 1 and go down. And when you got to 90, it'd be at 0. And when you got to 180, it would be negative 1 noodle at 180. All right, so there's 180. We're down at negative 1. Then you come down to 270, and it's no horizontal length at all. There's no horizontal at 270. When you get back to 0, you have 1 full noodle again horizontally. All right, so that's the full cycle for cosine, which is very much like sine, except for instead of starting at 0, it starts at 1, but it follows a similar path from a different starting point. You can notice some interesting things. One is wherever sine has a maximum or a minimum, cosine has a 0, an x-intercept. And wherever cosine has a maximum or a minimum, sine has a 0. Okay. Another thing to maybe notice is that if we were to shift cosine to the right, take the whole wave and shift it to the right so that it would shift it to the right by 90 degrees. So then instead of starting here, let's start. There we go. Let's start here. And then follow the cosine pattern. Then it would completely match up with sine. So cosine and sine are 90 degrees difference. Or we might call that, we call that a phase shift. I know I'm writing in some glittery colors. Hopefully you enjoy that. They're 90 degrees different. So if we shift cosine to the right by 90, then it would match up with sine. Or if we shift sine to the left by 90, then it would match up with cosine. Or if we think about it in radians, 90 degrees is the same thing as pi over 2 radians. Where did my screen go? 90 degrees is the same thing as what in radians? Pi over 2 radians. So then the phase shift between cosine and sine is pi over 2. So if you shifted cosine by pi over 2 radians to the right, then it would line up. Or if you shifted sine by pi over 2 radians to the left, then it would line up. So let me just kind of reiterate for the sine graph. So for f of x equals sine x, we can have these 5 fundamental points, or if we said radians, it would be this. Okay, sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, and sine of 360 is 0. So you have these 5 points. Start at 0. At 90, I'm up at 1. At 180, I'm back to 0. At 270, I'm down to negative 1. And 360, I'm back to 0. And that's your full cycle. All right, and then we could do the same thing for cosine. Or if we put it in radians, okay, cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. Cosine of 360 is 1. And here are your fundamental points for the cosine curve. Alrighty. Now we're going to talk about how to transform the basic parent sine and cosine functions. So let's look at the general sine wave. Okay, so now we have the parent function sine wave, but now we have these constants A, B, C, and D that transform this wave. Let's talk about what they do to the graph and what they might represent kind of in like a real life mathematical model. So A is the amplitude, which for the graph that means we could say you could define it two ways. The way I like to define it is the maximum distance from the center line. Another way to define it would be to say that it's the maximum value minus the minimum value divided by 2. That's another way you could say that. But that's the same thing as saying it's the distance, the distance that the highest and lowest points are from each other divided by 2 is the same thing as the distance that the highest point is from the center line, or the distance that the lowest point is from the center line. So that's saying the same thing, just in a little different way. Whichever way you want to think about it is fine. All right, in real life, this would be intensity, the intensity of the wave. So like for sound, it would be the volume. For light, it would be the brightness. For the ocean, it would be the height of the wave. So A is the amplitude. B affects the period / frequency. So B is not the frequency, but it affects the frequency in a particular way. A actually is the amplitude, but B is not the frequency or the period. It just affects it, and here's how it affects it. The period equals 2 pi over B. Or you could say the frequency is B over 2 pi. So the period and the frequency are reciprocals of one another. So we could write that too, 1 over the frequency. Or we could write the frequency as 1 over period. What is period? The period is the number of independent variable units it takes for a full cycle. So if the independent, most of the time in real life, the independent variable in this case would be time. So it would be the amount of time it takes to go through a full cycle. That's the period. It's the period of time it takes to go through a full cycle. So if you're looking at the sine wave, whatever this distance is, and this is notice this is the x, or the independent variable. or it might be t, or it might be something else. I didn't spell it right. Independent variable. This distance right here is the period. It's the amount of time or the number of units or whatever that measures that it takes to go through a full cycle. That's the period. The frequency is kind of the inverse of that. It's the number of cycles per unit of the per unit of the independent variable. So it's how many cycles it goes through. If we're talking about real life, it's probably the number of cycles per unit of time, the number of cycles per second or per minute or per year or whatever. So it would be like if this is the unit of time, let's say this is 1 second, and the sine wave did this, then it just went through 1/4 of its cycle in 1 second, and so the frequency would be 1/4 cycles per second. If this is 1 second and it did this, it would be a half of the cycle. So it would be the frequency would be a half. Or if it did this, all in 1 second, then it would be 1. The frequency would be 1 cycle per second. Okay. So the period and the frequency are inverses of one another. They're reciprocals of one another. And that you find both of them are determined by this letter B right here. Okay, so what is C? C is the horizontal shift or translation. The horizontal shift or the horizontal translation. In this case, aka the phase shift. Alright, so if C was 90 degrees, if it was x minus 90, that would mean that the graph would move 90 units or 90 degrees to the right. If C was negative 90, then it would be x minus negative 90, which would turn this into x plus 90 in here. Then it would move 90 degrees to the left. Or if it was x plus pi over 3, it would move pi over 3 radians to the left. Or if it was x minus 3 pi over 2, it would move 3 pi over 2 radians to the right. I hope I said that right. I couldn't remember what I said by the time I finished my sentence. But I hope I said that right. Hopefully you get it. It kind of moves in here in the opposite direction than what you would think. If it's minus, it moves to the right. If it's plus, it moves to the left, which is the same as what we've talked about earlier in the class with other transformations of parent functions. So in real life, this would just be like, it would be exactly what we said. It's a horizontal shift. If somebody was speaking to you with the sound, it would mean that they would move toward you or move away from you. So I guess you'd call it a forward or backward shift in that case, which would shift the phase. That's why if someone is, if a train is coming toward you, the pitch is higher than it sounds than when the train passes by and is moving away from you. I think that's called the Doppler effect. It's because it's a phase shift, and it's kind of affecting the frequency as well. All right. D is the, you probably already know, the vertical shift. So it shifts it up and down, and it's real simple. It's exactly what it says. If you add 3, it just shifts the whole graph up by 3. If you subtract 4, it just moves the whole graph down by 4. But you could also say that D is the vertical location of the center line. aka equilibrium line. All right. Cosine acts the exact same way. So you'd have this would be the exact same. I would write all of these same things would be exactly the same, except that I would just replace sine with cosine, and it would be exactly the same. All these letters would mean the same thing. They would do the same thing to cosine as they would to sine. All right, here is an example. We're going to take this. Kind of covers all the phases of what we have to do to make a whole transformation of a function, like the sine curve. So the first thing you want to do is put it into this format right here. We need to make it match this format. And the thing that we don't have over here that we can make it fit here is they have whatever's in front of x, you have to factor that out. So whatever's in front of x, we want to factor that out. So let's rewrite this. And instead of 3x, I'm going to factor the 3 out. And when I factor 3 out, we're left with the x here. And if I factor a 3 out of the pi, that means I'm dividing 3 out of pi. So it just leaves me with pi over 3. And just think about if I were to distribute the 3 into this, it would give me 3x plus and then 3 pi over 3. The 3's would cancel and you'd have pi. Okay? So now we're in the proper format where now we know the a is 2, the b is 3, the c is pi over 3, and the d is 1. So let's just get the information. What is the amplitude? The amplitude is 2 from the fact that that 2 is in front of everything. That 2 is the a, which is the amplitude. The period is 2 pi divided by b. In this case, b is 3. So the period is 2 pi over 3. The frequency is the inverse of that, or the reciprocal, which is 3 over 2 pi. The phase shift, or the horizontal shift, is negative pi over 3. Right? Because it's the opposite of what's in here. And the vertical shift is 1, or we could say the center line is 1. Okay. So let's now, we've got all the information, but there's a process we need to go through for this graph. Here is kind of part of that process. Might be kind of confusing at first, but starting point is the phase shift. So normally sine starts at 0, right? We start at 0, but since this thing is shifted, it has a phase shift, it's shifted to the left by pi over 3. Now we're going to not start at 0. The cycle doesn't start at 0. The cycle starts at negative pi over 3. So our starting point is negative pi over 3. And then what I want you to do from there is get your steps. Like how much are we going to go over before we have another fundamental point? So to get the other 4 points, divide the period by 4. So whatever the period is, divide that by 4, and that will get you kind of the steps that need to be taken to get the other 4 points in the cycle. So let's take our period. So the steps will be 2 pi over 3 divided by 4. Or you could say 2 pi over 3 times 1/4, which is 2 pi over 12, or we could reduce that to pi over 6. Okay, so each fundamental point is going to come instead of, they used to come pi over 2. Every pi over 2 radians or every 90 degrees we had a new fundamental point. But in this one, because it has a different frequency, a different period, the fundamental points are going to come every pi over 6 units. Okay? So here's what that kind of looks like. I'm going to start not at 0, but at negative pi over 3. And then my next point, my next x coordinate will be pi over 6 more. I go another pi over 6. So I got to add pi over 6 to negative pi over 3. And I got to get a common denominator. Well, negative pi over 3 is the same thing as negative 2 pi over 6. Just be multiplying the top and the bottom by 2. So negative 2 pi over 6 plus 1 pi over 6, that is negative 1 pi over 6. So negative pi over 6 is my next step in the x direction. And then I add another pi over 6 to that. Well, what if I add pi over 6 to negative pi over 6? That gets me to 0. So that's the next point. And then I add pi over 6 again. That gets me pi over 6. Add pi over 6 to 0, you get pi over 6. Then I add pi over 6 again, I get 2 pi over 6. Well, that reduces 2 pi over 3. Feel free to pause this video just to soak in or rewind it or whatever to see if something kind of went by you too fast. And the y coordinates, they kind of, what I would recommend maybe is write down what they normally are, right? Normally it would be 0, 1, 0, negative 1, 0 for the sine function. For the cosine function, it would be 1, 0, negative 1, 0, 1. All right, and then transform these by multiplying by the amplitude and then adding the vertical shift. So I multiply by the amplitude, which is 2, and I add the vertical shift, which is 1. So multiply this by 2. 0 times 2 is 0. Add 1, that's 1. 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. Negative 1 times 2 is negative 2, plus 1 is negative 1. And make sure I've done that right. Negative 1 times 2 is negative 2, and then plus 1 is negative 1. That's right. And again, negative 2 times 0 is 0, plus 1 is 1. So here are my ordered pairs. These values paired with these values are the ordered pairs that I'm going to graph. So let's begin our graphing process here. All right, on the horizontal axis, I'm going to start at negative pi over 3. Then I'm going to go negative pi over 6, then 0. So this is going to be negative pi over 3. This is negative pi over 6, then 0, then pi over 6, then pi over 3. Okay, then I have my y coordinates. They are 1, 3, 1, negative 1, 1. And here is my fundamental cycle for that function. Notice that my center line is 1. Notice that my amplitude is 2, right? Is 2 away from the center line. Or the other way you can think about it is the distance between the highest and lowest points is 4, and divide that in half, and the amplitude is 2, which is exactly what it should be. Right? The phase shift, it has shifted to the left by pi over 3. The period is 2 pi over 3, right? The distance here, the distance for a full cycle, the number of independent variable units that it takes for a full cycle, is the distance from pi over 3 to negative pi over 3. Well, pi over 3 minus negative pi over 3 is 2 pi over 3, which is exactly what the period is supposed to be. The frequency is 3 over 2 pi. That's a weird number to think about. It's kind of like, what sense does that make? Let's see, 2 times 3.1 is about 3/6, so about a half. So it goes through about a half of a cycle every unit on the x-axis. For every 1 unit on the x-axis, it goes through a little less than half a cycle. And that's it. That's the whole example. If you can get that example, then you've got this section whipped. So let's look at a problem like number 15 on your homework. This is kind of the opposite way. This time we're given the information about the graph, and we're told to make the function from there. So let's see, this is the period, the given period. So this is the period, the phase shift. And this is the range, and the range will give us, that'll help us to know where the center line is, and also know what the amplitude is. So let's take that kind of one thing at a time here. All right, remember the period is 2 pi over b. So if we want to know what b is, let's take the period that they gave us, pi over 2, and set it equal to 2 pi over b. And then just solve for b. So we could just cross multiply. So pi b equals 4 pi when we cross multiply. Divide by pi on both sides. And b equals 4. All right, so b equals 4. We've got that figured out. Okay. Next, what do we want to get now? I could easily know C. Remember, C is equal to the phase shift. So C is pi over 6. Let's go ahead and get A. A would be the amplitude. Well, if the range goes from 2 all the way to 10, then the amplitude would be half of this distance. So 10 minus 2 is 8, so half of that is 4. So A is 4, right? You see what I'm saying there? Like this distance is 8. So the amplitude is half the distance between those two maximum and minimum points. And D is the average of these two things. It's what's right in the middle. Okay, what is right in the middle here? 2, 3, 4, 5, 6. So D is 6. Another way you could get that is just to average them by adding them. 10 plus 2, then divided by how many there are, which is 2. So that's 12 over 2, which is 6. So now I should be able to pick out my function from there. It would be y equals 4 times cosine of 4 parentheses, 4 parentheses, x minus pi over 6, parentheses, plus 6. So the answer appears to be choice C. Alright, we're going to stop this video here. We may make another video about how to do some of these word problems if you have trouble with that, or we may just take a look at those in class together. But either way, good luck on your homework assignment for 5.3.